Could the coronavirus vaccine actually provide protection against the common cold? Many of us refer to COVID-19 as coronavirus, which is actually the name of a family of viruses that includes SARS and the common cold. A new study shows that vaccination against a coronavirus or previous infection can provide protection against other viruses in that same family. And joining us to talk about the study is one of its authors, Pablo Peñalosa-McMaster, Assistant Professor of Microbiology and Immunology at Northwestern University's Feinberg School of Medicine. Thanks for being here with us.
Thank you, Paris. Thank you for the invitation.
Well, it's good to have you. And as we just mentioned, coronavirus, we've heard a lot about COVID-19, but it belongs to the larger family of coronaviruses. So explain what a coronavirus is.
Right. So coronaviruses are RNA viruses. They're very large, and they, believe it or not, they have an error correcting mechanism. So it's not, they're not as mutable as flu viruses or as HIV. So in a way, they're RNA viruses that are very large and have a way to correcting their errors. But sporadically, they make mistakes, and that's the basis for variants. That's how variants evolve. It's just by those little mistakes that the error-proof polymerase cannot make. But in a summary, coronaviruses are just a big family of RNA viruses.
So there's not a whole lot of variation unless, as you mentioned, there's a mistake like the Delta variant and others. And your study demonstrated that vaccination against COVID-19 might actually provide immunity against other coronaviruses. Explain that.
Right, exactly. So we look at this both in humans as well as in mice, and we took humans who received the RNA vaccines and also the J&J vaccine, and we noticed that those the antibodies that were elicited in vaccinated humans also cross-reacted with other coronaviruses, suggesting that they could potentially protect against other coronaviruses. We did this in vitro studies, but also in other mouse studies, mice that received SARS-CoV-2 vaccines or SARS-CoV-1 vaccine, and then we noticed that they were also protected against other coronaviruses. So what this suggests is that if you think about future pandemic, you might not necessarily need to make a vaccine from scratch based on the emerging virus. You could potentially piggyback on a prior vaccine that has a related sequence.
And there's kind of already, and as you mentioned, the roadmap is already here with the current vaccine. Now, we mentioned the common cold is related to this family of coronaviruses. Does that mean there could be immunity to the common cold if you're vaccinated against COVID-19?
Precisely. So partial immunity. So what we did is that we first vaccinated mice with a SARS-CoV-1 vaccine that was developed almost 20 years ago. And these mice that received the SARS-1 vaccine were also protected against SARS-2. But then we decided to go a little bit further because SARS-1 and SARS-2 are genetically related. They're like cousins of one another. They're almost 80% identical. But then we decided to look at a more distant challenge. So we vaccinated mice with a SARS-2 vaccine, and then we exposed them with the common cold coronavirus, OC43, which is around 40% related. So it's a lot more distant. And there was partial protection. Wow. So whenever it comes to protection, it really depends how close the virus is to the vaccine.
Right. I mean, there is no one uniform common cold virus. I don't think this is scientifically relevant, but I haven't had so much as a sniffle since I've been vaccinated. So does this mean researchers might want to develop a universal coronavirus vaccine that could, as you said, help against future pandemics?
Right. And in a way, the more realistic way is just to making generic vaccines based on specific families instead of just one vaccine that could control all different coronaviruses. I think that's unrealistic because these viruses are tremendously heterogeneous, but it's more realistic to think about specific coronavirus families, right? So in that context, what our paper showed is that if you just use a vaccine that is developed for a SARS-related virus, then you get protection against many of the SARS-related viruses, including SARS-1 and SARS-2.
Very interesting. There's another study with some fascinating results that you were a part of, and this involves AstraZeneca, and the participants in this were accidentally given a lower first dose of the shot, and that actually caused perhaps greater immunity. Explain that for us.
Right. When it comes to the immune system, sometimes less is more. And what we found is that a very low dose of vaccine, this is an adenovirus vector vaccine, which is somewhat similar to the J&J, but it's based on Ad5, which is mostly, is very similar to the CanSino one that is used in China. But what we show is that a very gentle primary immunization with a very low dose of vaccine and then booster with the standard dose was better than standard dose. So it's funny because whenever it comes to the immune system, sometimes less is more. And with the low dose, you get a qualitatively superior response that could expand better upon a subsequent booster immunization.
In lay terms, can you explain why that is?
Yeah, it's not very clear why that is the case, but it seems like with the low dose, you get this so-called central memory T cell response. And it's basically cells that are quantitatively, it's less of a response, but qualitatively is better. So the cells have better quality. We don't really understand why you get this superior quality, but then once you get the booster, they expand a lot better. So those memory T cells, those antibodies, that response expands better. It's not very clear why that's, but it could be related to the quality of the immune response when you give a very low dose of vaccine.
Very quickly, we only have a couple seconds left, but does that mean that folks might want to think about altering the dosage? I mean, if they haven't gotten their first or second or booster shot yet?
No, I think we should follow what the FDA says. I don't want to make policy with this, but this is something that could inform future vaccine design, not only for SARS-CoV-2, but potentially for other diseases, in a way of how we design vaccines, how we make clinical trials. Maybe we should also test dose escalation within the same cohorts.
All right, so very interesting for future inquiry. And our thanks to Pablo Peñalosa McMaster. Thanks for joining us.
Thank you, Paris.